Hey everyone, welcome to another episode of Philip in the Cloud. We're going to be streaming about Ibis today, talking about how you can use Ibis to do some plotting. Now, in the past, Ibis has not been able to do plotting for various reasons, but we recently implemented something called the array interface, which is part of NumPy's API that will automatically kind of work with matplotlib, and we're going to show that today here. Okay, so I fired up a shell and I've actually got a plotting window hidden that I'll show here in a little bit. So let's just import matplotlib.pyplot, which is kind of the matplotlib convenience API. We'll import Ibis, and then we will fire up a connection to DuckDB. And the data set we're going to be looking at is Movie Lens, which is kind of a classic test data set for analytics tools. And what we're going to be showing is specific trends over time. So let's fire up our tables. We're going to pull in the movies table, and also let's set our interactive repr to true. And we look at our movies, and we see we've got a movie ID, a title, and a genre, and a kind of a pipe-separated list of genres. And then let's also pull in the ratings from the same data set. We see we've got ratings, user ID, movie ID, rating, and timestamp. Let's look at how many ratings there are. We've got about 25 million, I believe that is, and let's see, about 62,000 movies. So let's look at movies. Let's look at ratings. Sorry, let's look at movies again. Let's say let's just pick a genre here and see, what the rating of a particular thing, of a particular genre was over time. So let's pick animation and see how the rating has fluctuated over time. So of course, we don't have ratings in our movies data set. So what we need to do is join that with movies, right? Join movies to ratings. They both have the movie ID column, of course, so you can write it like this in Ibis for shorthand convenience. You can also just use an explicit equality expression, movies.movie ID equals ratings.movie ID. And we can look at the first few rows of that. We've got, of course, our movie ID, title, genres, user ID, which we don't really care about, and rating and timestamp. So of course, you'll notice that the timestamp is in some kind of integer. That's second since the epoch. It's a Unix timestamp. So let's basically just cast that to an actual timestamp that we can work with to get extract the year, right? Because otherwise we'd have to sort of do our own calculations, and that's not fun. So we can use the underscore API here and mutate. So we get a timestamp underscore dot timestamp dot cast, and cast it to a timestamp. Got our join table. Now we've got a nice timestamp there. Still got all of our other columns, which is pretty sweet. And then ultimately the calculation we want to do is just kind of average over time, over year, the rating for every movie that has the genre animation in it. So first, let's find all the animation movies here. We've got join.genre, and if you want to look at a timestamp, if you want to look at a string and whether a particular string is a substring of another string, you can use the contains API on string columns. So in this case, we're interested in animation, right? Let's confirm that we got what we want, at least to the first approximation. We're finding Nemo, Shrek, Toy Story, The Lion King, Aladdin, Mulan, Little Mermaid, etc. And all these rows have the substring animation in the genre string. Great. So now for animations, we care about the average for animation genres. we care about the rating over each year, right? So the first thing, so what we want to do is do a group by on timestamp, but not just timestamp, right? Because that's seconds based, so it's going to give us. It's probably not going to be super useful. In fact, it may just be one row per timestamp because they're very unique. So we want to pull off the year, which is a method on timestamp columns. And just to be sure that we get the name we want and not some automatically generated name, we can say year equals and then give our expression. And then we want to aggregate that into an average rating. Let's call that average rating. We could do the same underscore API rating dot mean. Let's call that average ratings. Let's look at it. Cool, we've got our years. They appear to be in a random order or a non-deterministic order, which makes sense because we don't have an order by there. But for plotting, we're going to want that, right? So let's modify that expression to say order by year. That should be sufficient. Cool, so now we've got sorted year and average ratings. And of course, as always, you should be able to look at the SQL of this and see it's kind of gnarly. If we scroll up, we can see that we're sort of incrementally building up that expression and generating the SQL. All right, let's look at our table again. And here's where sort of the interesting stuff comes, right? We've got, let me turn on the plotting window. Hopefully that shows up nicely. Should be up there in the top right corner. And let's call plot.cla, clear the axes, and then let's call plot.scatter average ratings.year, average ratings.average rating. Sweet, so we actually have a scatter plot there. Let's clear it again because it's sort of hard to see any kind of trend there. It's maybe going up and down. Let's clear the axes again. And let's just do regular old plot to get a line plot. Okay, so we have sent some Ibis expressions into the matplotlib API kind of transparently. They were executed. The NumPy arrays were pulled out and it was plotted. And we can see that the rating of animation movies over time appears to fluctuate a little bit. If we look at the y-axis, we see that it's fluctuating between 0.2 or maybe 1.75 thereabouts. So the automatic scaling of matplotlib is kind of artificially, I think, inflating the magnitude of the fluctuation, but it does appear to fluctuate at least a little bit. And that is all for today, and that is how you plot with Ibis. Get involved if you're interested. You can go to ibis-project.org, and that is the homepage for the site. Thanks, everyone. See you next time.